Welcome to my another Blue Pill project. The idea is to make a soldering station capable of controlling temperature of 220 volts soldering irons. For this purpose, the heating element of the soldering iron is used as a temperature sensor. To find the resistance of the heating element, we will measure the voltage and current of the element and apply Ohm's law. This video demonstrates the principle of ADC, analog to digital converter, sampling synchronization with the MOSFET control pulse. As you see, by controlling the width of the pulse, the sampling take place exactly at the middle of the pulse. The modes of operation: the manual mode for power control, and we use the auto mode for the temperature control with PID regulator, and the same in the rest mode, but when the soldering iron is idle, we are not using it. And we also can choose which soldering iron we use. I found it convenient to find correlation between the power applied to the heating element and soldering iron tip temperature. We will do a number of measurements for different soldering iron, and later we can plot a graph for future reference. In our case, we use two soldering iron, 40 watt and 60 watt. 55% of rated power. And you can see also virtual resistance. The graphs presented for the tip temperature, virtual resistance and virtual current against the pulse width modulation. Now let's check the operation of 40 watts soldering iron in auto or working mode. Set temperature of the soldering iron is 250 degrees centigrade. The PID regulator controls parameters of the pulse width modulation such that power applied to the heating element will increase resistance of the heating element equivalent to the set temperature. Mind that though the heating element temperature is rising fairly fast, the tip of the soldering iron will heat up at much slower rate. And at the display we can see the set temperature and the actual temperature as equivalent to the resistance of the heating element. When the power reading is stable, we can use the graph to estimate the tip temperature. Let's do it for another temperature setting, 285 degrees centigrade. As you may notice, the PID regulator has a boost feature which provides higher value of the power at the beginning of the heating stage in order to speed up the process. Again, I would like to remind you that the temperature shown at the display is actual the temperature of the heating element. The temperature of the tip will change at slower rate. This test is for 40 watts soldering iron. Again, we can use the graph to estimate the tip temperature. Of course, it's approximate estimation. Schematic diagram for the controls, inputs and outputs. Schematic diagram of the differential amplifier and switch of the type of soldering iron. The power module. There is nothing special. The internal components: control module, differential amplifier, PCB, power module. The demonstration how to adjust work and idle temperature on fly. There is also the TADJ option, which allows to correct the actual temperature reading if required. It is optional feature. The benefits and drawbacks of the soldering station. You can read it. And the diagram demonstration of PID regulator functioning. This is attempt to read temperature of the tip with infrared thermometer. That's all for today.